Hey everyone, picture this. It's 3 a.m. Your phone lights up with yet another pipeline failure alert. Because data drift just killed your downstream LLM's accuracy, and you're staring at endless logs wondering why you're still babysitting code that should just work on its own. Now imagine waking up the next morning to fresh, clean, perfectly adapted data flowing through, because your pipelines not only fixed themselves overnight, but actually learned from the LLM's own feedback and proactively improved the next run without you lifting a finger. That future isn't distant science fiction, it's the emerging reality of autonomous agentic data pipelines, and over the next 5 to 10 years, this is precisely how every serious data team will be operating to stay competitive. If you're a data engineer or analyst who is exhausted from dealing with fragile ETL jobs, constant manual interventions, and pipelines that crumble the instant real-world conditions shift even slightly, then stay with me for the next several minutes, because I'm going to walk you through exactly how to build these self-healing and self-adapting systems step by step. These systems transform your data infrastructure from a perpetual source of stress and downtime into a living, intelligent partner that evolves alongside your AI applications and solves the exact problems that keep you up at night. The pain points we face every day are intensifying as data volumes continue to explode and AI demands ever higher levels of freshness, accuracy, and reliability. Traditional pipelines operate under the flawed assumption that the world remains static with unchanging schemas, flawless data quality, and predictable data volumes. In reality, schema changes arrive without any advance notice from upstream teams. Data sources become flaky or inconsistent overnight. Subtle quality degradations creep in silently, and volume spikes create unexpected bottlenecks. By the time these issues surface in alerts or reports, the damage is already done downstream. LLMs begin producing hallucinated outputs, analytics dashboards display misleading insights, and business decisions suffer. Data engineers end up spending countless hours on tedious root cause investigations, emergency reruns, and emergency hotfixes, all while valuable business opportunities slip away and unnecessary compute costs pile up from repeated failed executions. To put numbers on it, many teams report spending up to 80% of their time on maintenance rather than value-adding work. The real killer is the feedback gap. Your pipeline has no idea how its output actually performs in the LLM or AI application sitting on top of it. So problems compound instead of getting fixed at the source. Small issues snowball into major outages, trust erodes, and teams remain stuck in reactive mode. Agentic pipelines solve this by embedding intelligence directly into the flow autonomous AI agents that don't just move data, but observe, reason, act, and learn continuously, creating a virtuous cycle where the system gets smarter with every run and directly tackles the root causes that waste your time. At its core, an agentic data pipeline replaces rigid directed acyclic graphs with a dynamic loop powered by large language models, acting as intelligent agents. These agents use reasoning patterns like breaking complex problems into steps, calling tools for specific actions, observing the results, and iterating until the goal is achieved. Think of it as giving your pipeline a team of specialized coworkers working in harmony. One monitors everything in real time, another diagnoses root causes using comprehensive lineage and logs, a third executes fixes, and a fourth validates the outcome and stores lessons learned, so the next incident is handled even faster. The magic happens when you close the loop with direct feedback from your LLMs and AI applications. Every time your downstream model runs inference, you capture signals like confidence scores, user ratings, hallucination flags, or evaluation metrics. Then feed those straight back into the pipeline agents so they can adjust transformations, enrich context, regenerate embeddings, or even trigger synthetic data creation to fill gaps before they become problems. This closed loop turns one-off fixes into permanent institutional knowledge that prevents recurring issues and keeps your data reliable for years ahead. Let's walk through exactly how you build this in practice so you can start solving these problems immediately and see real results within weeks. You begin with a rock-solid observability foundation because autonomy without visibility is a recipe for disaster. Instrument every step of your pipeline. with comprehensive metrics covering data freshness, volume trends, schema consistency, completeness percentages, statistical distributions, and end-to-end lineage tracking. This gives you real-time visibility into anomalies and the context agents need to make informed decisions. Next, you layer on a multi-agent orchestration layer using stateful frameworks that let agents maintain memory across runs, remember past incidents, and collaborate seamlessly. Your first agent is the monitor. It runs continuously, comparing live data against historical baselines and predefined quality rules. When it spots something off, say a sudden spike in null values or a schema drift, it doesn't just alert, it packages the evidence, including recent logs, affected records, upstream changes, and downstream LLM performance scores, then hands it to the diagnostic agent. The diagnostic agent analyzes the context, cross-references your knowledge base of past incidents, reasons through possible causes like a column rename combined with a brittle join, and outputs a structured plan with confidence scores. Then the fixer agent takes over using a try-heal-retry cycle. It can retry with adjusted parameters, quarantine bad records, rewrite a transformation on the fly using generated code validated in a sandbox, scale compute resources automatically, or propose a schema evolution that gets reviewed in shadow mode first. The entire cycle happens in seconds. Catch the failure, send the full context, get back a corrected action, execute it safely, and measure the outcome. If the fix works, the learning agent stores the entire episode so future issues are resolved faster without human input. What makes this truly powerful and future-proof is the closed feedback loop from your LLMs. Every inference run produces rich signals. Did the retrieved context lead to accurate answers? Were there hallucinations traceable to bad data? How did latency or cost behave? Those signals flow back as events into your pipeline. The agents use them to refine upstream steps. They automatically improve chunking strategies for better embeddings, adjust filtering to prioritize higher quality sources, or generate targeted synthetic data to balance distributions that were causing model drift. Over time, your entire system becomes self-optimizing, not just healing failures, but proactively tuning itself for better downstream performance, lower costs, and higher reliability. You'll see automatic handling of seasonal data shifts, real-time adaptation to new regulatory requirements, or cost-aware routing that moves workloads to cheaper compute when quality allows. These practical wins come from the exact mechanisms that address the daily frustrations data teams face, like silent quality drops or inefficient resource use that inflate bills and slow down insights. Implementing this safely is crucial because you're giving agents real power over production data. Start in shadow mode. Run the agentic layer in parallel with your existing pipeline for weeks. Let it propose fixes but require human approval until trust is earned. Use structured outputs from your LLMs so every plan, diagnosis, and fix is machine-readable and auditable. Build in strong guardrails. Define clear boundaries on what agents can and cannot change. Maintain human-in-the-loop escalation paths for high-impact decisions, and log every reasoning step and action for compliance and debugging. Integrate with your modern data platform so agents have fast access to metadata, lineage, and historical patterns without scanning raw data unnecessarily. This setup ensures the system scales safely while solving problems like transient failures or cost overruns that traditional pipelines leave you manually fixing over and over. Let me give you concrete examples of the problems this solves that you're probably facing right now. Schema drift hits, and traditionally your pipeline explodes with agentic design. The diagnostic agent spots the mismatch, reasons it's a renamed column based on similarity scores and lineage. Then the fixer generates and applies a mapping transformation automatically, while preserving downstream compatibility. Data quality silently degrades, and your LLM starts returning low-confidence answers. The feedback loop catches the drop in evaluation scores, triggers the agents to isolate the offending batch, enrich it with missing context from external sources, and retrain the quality rules so it never happens again. Transient failures from upstream API rate limits used to cause hours of downtime. Now the monitor detects the pattern. The fixer applies exponential backoff, with adaptive parameters suggested by the LLM, retries successfully, and updates the policy for next time. Cost overruns from inefficient transformations get optimized because agents analyze usage patterns and rewrite queries or switch storage formats on the fly. These aren't theoretical wins. Teams implementing even basic versions report cutting manual intervention by 80% or more within months, freeing you to focus on innovation instead of firefighting the same issues repeatedly. As you scale this across your organization, focus on progressive autonomy. Begin with one critical pipeline that feeds your most important LLM application. Prove the value through faster time to insight, lower operational costs, higher model accuracy, and engineers spending time on innovation instead of firefighting. Governance stays front and center. Every autonomous action is traceable, reversible, and aligned with your data contracts and compliance rules. This approach future-proofs you because the same agentic patterns will handle tomorrow's challenges, like multimodal data streams or hybrid compute workloads, all while keeping humans firmly in control of strategy and oversight for the next decade and beyond. By building these autonomous agentic data pipelines that self-heal and adapt through LLM feedback loops, you're not just fixing today's headaches, you're creating infrastructure that actually gets smarter every single day. Your data becomes more reliable, your AI applications more accurate, and your entire team more strategic. If you're ready to stop reacting and start leading the next decade of data engineering, the blueprint is right here in front of you. Start small with observability and one agent loop. Iterate fast based on real feedback, measure relentlessly against both technical and business metrics, and watch your pipelines evolve from fragile scripts into intelligent systems that work for you. Drop a comment with the biggest pipeline pain you're facing right now. I read every single one, and let's keep pushing this field forward together. Thanks for watching, and I'll see you in the next video where we dive even deeper into real examples.